Hi everyone, Samar here and welcome back to GoDevOps. So in the previous episodes, we ran a container using Podman and everything worked instantly. But what we actually used behind the scenes was a container image, and that's something we never really explored in details. So today we fixed that. We're going to see what an image is in Podman, how Podman finds it, where it comes from, and how we manage it in real workflows. So let's start. In Podman, a container image is a package file system that contains everything needed to run an application. So binaries, dependencies, configuration, and metadata. But unlike a simple file you download, Podman treats images as references that come from registries. So when we say Nginx image, we are not talking about something local on our machine. We're talking about something that usually lives remotely in a registry, and Podman fetches it when needed. Now, the important question is, where does Podman actually get these images from? So images are not local by default. Podman pulls them from container registries, and a registry is basically a remote storage system for container images. So you can think of it as a central place where images are stored, versioned, and shared across the system. Now let's run a Podman search command. And let's take the example of Nginx. So Podman can search across configured registries, and this helps us discover images before pooling them. So here we will take the example of this image and we will pool it with the Podman pool command. So docker library Nginx. So here we notice that Podman downloads multiple layers instead of a single file, and that's because container images are built in layers and not as one monolithic object. And once pooled, the image is stored locally, so the next time we run it, Podman does not download it again. So now that we have our image locally, we need to manage them like real infrastructure assets, because in a real environment, images are not just files sitting on a machine. They are versions, artifacts that needs to be inspected, organized, and sometimes cleaned up. So let's start by observing what we currently have on our system with a Podman Images command. So this command lists all the images currently stored locally by Podman, and each image represents here a file system snapshot that can be reused to create containers instantly without downloading anything again. And now one of the most important concepts in image management is tagging. So tagging allows us to create multiple logical references to the same image without duplicating it. So let's apply a new tag to an existing image. So the image that we have just pulled with the Podman tag command, and we have to put the image name Nginx, and the name that we will choose for it is my Nginx, for example. Okay, and now if we list the images again with Podman Images, here we have both the normal Nginx image and the new my Nginx image appear, but here's the key point. They are not two different images. They both point to the exact same image ID as we see here. And this is extremely important in real-world systems because tagging is not duplication. It is simply another label pointing to the same underlying image layers. And that means we can version, rename, or organize images without wasting storage. Now let's go one level deeper and inspect what is actually inside an image with Podman inspect command. Let's take my engine's image, for example. So here the inspect command gives us full metadata about the image, and this includes ports, for example, environment variables, entry point, and much more. So in other words, it tells us how the container will behave before we even run it. And this is one of the most powerful debugging and analysis tools in Podman, because it lets us understand the image without executing it. And now we finally can talk about cleanup, so removing images with the Podman command, and we will remove my engine's image, for example. And the important rule here is that you must always remember that images cannot be removed if they are currently being used by a container, because Podman ensures that no running or existing container depends on missing layers. Now we move from using images to creating our own. So until now we've been pooling and managing images created by others. But in real DevOps workflows, we often need to build our own images, customize them, and distribute them across environments. So let's go through a full real-world image lifecycle, so from the build to run to versioning and even export and restore. So let's start by creating a container file. And in this container file, we will just start from an existing base image. So we will take, for example, the engine's image that we have. Engines. And then we add our own custom HTML file on top of it, with copy index HTML. I have already created my index.html file, so I can use it here. And so this is the foundation of image customization, so layering your own content on top of a base image. Now we build our custom image with Podman build command. We will name it my engines. And we will use the container file. So here Podman reads the container file and executes each instruction and creates a new image layer by layer. And each step in the file becomes part of the final image that we have. And now we will run our custom image as a container with Podman run. And we will use port mapping and our image, my engines. Okay, so here we have created the container. We can verify the port mapping and verify if our container is actually working. Host 8080. So it is working. This confirms that our image build process worked correctly. So what's important here is to understand the transformation process, because we actually have started from a simple text file, so the container file, and we ended up with a fully functional and runnable system. And now we will introduce versioning using tags like we have already done. So we will tag our image, my engines, and we can add a simple tag like 0.1. Okay, and this is extremely important in real CI/CD pipelines because in CI/CD pipelines we have multiple versions of an image that coexist. And now we move into image portability. So we will save the image with Podman save for our my engines image. Okay, so the save command allows us to export the full image into a tar archive. And this is very important because it preserves all the layers of the image and even the history of the image. Now we will simulate a real-world scenario where the image is removed from the system. My engines. So at this point, if we didn't save it, the image would be gone. But of course we have already saved it, so now we can restore the image from the saved archive with Podman load command. So the load command re-imports the image exactly as it was, including layers and metadata. And here what we just did is a full image lifecycle. So we started by building a custom image, we run it, we version it, we exported it, deleted it, and finally restored it. So this is exactly how images are handled in real DevOps workflows. So not just in theory, but even in production pipelines. At this point, you should understand one key idea is that Podman does not run images, it orchestrates them from registries into containers. Now let's simplify everything we saw today into one mental model that you should always keep in mind. So the first step is images come from registries, and these registries are remote storage systems that host container images, and when we execute a pull, Podman downloads those images locally. So now the image is stored on our machine in the local image store, and from there, when we execute a Podman run, Podman creates a container from that image. And a container is just a running instance of that image with an isolated process. And finally, this runtime produces the running container that we interact with. So the full chain here is always the same. So we start from the registry, then the image, then the container runtime, and finally a running container. And this is the mental model you should always come back to whenever you use Podman in real environments. Now, understand images and registries, but there is still one missing piece. So how do we actually define our own images in a repeatable way? And that's what we'll see in the next episode. So we're going to build real images using container files. And if you enjoyed this video and want to follow the rest of the series, don't forget to like the video and to subscribe, and see you in the next one. Thank you.